Also, in this, we will discuss LeetCode problem number 523, continuous Subarray Sum. So, what is the statement? Statement is that given an integer array nums and integer k, return true if nums has a good Subarray or false otherwise. So, we will be given two things. One is the integer array and another is a variable integer k. So, I have to return that there is any good Subarray possible or not. If it is possible, then I have to return true, otherwise, I have to return false. So, what is good Subarray? Good Subarray is that length should be at least 2, the length of the subarray, and the sum of the elements of the subarray is multiple of k. So the sum of that subarray will be divisible by k. That actually they are trying to say that subarray is multiple of k. Multiple of k means modulo of k will be 0. Remainder will be 0, right? So a subarray is a continuous part of the array, and integer x is a multiple of k if there exists integer n such that x is equal to n into k. 0 is always a multiple of k. Okay, so let's take the example. This is 23, 2, 4, 6, 7, and k is equal to 6, right? So continuous Subarray, so I can actually generate all the possible Subarray, like 23, one possible Subarray, then 23 and 2, then 23, 2 and 4, then 23, 2, 4, 6, then 23, 2, 4, 6, 7. Okay, next possible is like 2 only, then 2, 4, then 2, 4, 6, then 2, 4, 6, 7. Got it? Then 4, 4, 6, 4, 6, 7. Got it? Then possible Subarray is like starting from 6, 6, then 6, 7. Next is only 7. Okay. So you know, right, how can I generate actually in this actually all possible Subarray? Like I have to take two pointer, like one is the starting pointer and another is the ending pointer of the current Subarray, which is starting from the starting pointing the starting Subarray. Now we generate all the possible Subarray here. Now I will check for sum of each Subarray. Like here actually sum is 23, here actually 25, here actually 29, here actually like 35, then here is 42, then here actually 2, here actually 6, here actually 12, here actually 2, 4, 6, 7 means 19, here actually 4, 10, 17, 6, 13. This is 7. So now we will get the sum of the all possible Subarray. Now I'll check is there any sum present or actually divisible by k. So I will check 23 modulo of k is 6 is equal to 0. No, it is not 0. Then I'll check 25 modulo of 6 is equal to 0. No. Then I'll check 29 modulo of 6 is equal to 0. No. Then I'll check 35 modulo of 6 is equal to 0. No. Then I'll check 42 modulo of 6 is equal to 0. Yes, this is 0. Such 7 into 6 is equal to 42. So this actually I have to return true that time. Got it? That's why this answer will be true. So what is the time study for this brute force approach? You know, right? I will be taking two pointer starting from L is equal to 0, L less than n minus 1, and L plus plus, and I will take another right pointer of the current Subarray to generate all those. It will starting from L and R less than n R plus plus. Got it? In this actually we actually take generate all the possible Subarray. So for this two nested loop, what are the times of this big of n square? And here actually I will add a sum plus is equal to like nums of r, because this will be added into the current Subarray. That's why sum will be also added to the current Subarray. So what are the times of big of n square? So but yet in limit of time constant is n less than equal to 10 to the power 5. So if I take the n square, it will be 10 to the power 10. This will not cross the time limit. So this is actually not possible. So let's go to the some optimal approach. Now take some observation. Like if I take 1, 2, 3, 4, 5, then 6, 7, 8, 9, 10. Okay, this is our integer array and k is equal to suppose 5. Okay, so I have to find out that is there any subarray whose sum is divisible by k or not, means 5 or not. So let's generate all this subarray first. 1, 2, 3. So 1, 2, 3. What is the sum? 1 plus 2 plus 3 is equal to 6. Right? If I take modulo of 5, it is not equal to 0. And if I take this only, 2 and 3, what is the sum? Sum is 5. 5 modulo of 5 is equal to 0. So this should return true. Now on observation, like if I am taking 2 and 3, right? So if I do the prefix sum here, it will not be able to calculate this. How? Like prefix sum is like 1, first sum is 1, then 1 plus 2 will be 3, then 3 plus 3 will be 6. Like how I will note that there is a 1 is present or not, right? In between the sum is 5, because if I do 6 minus 1, then I will get 5, which is 5 modulo 5 is equal to 0. Right. So if I find out that if I have to subtract all the possible uh, previous numbers I have seen, then I have to actually, it will be again times it will be n square, because one loop will be go iterate the array, and again, and for each number I have to check that is there any number which is difference of like current sum and previous sum I have seen till now, difference is divisible by k or not. That time again it will take the n square time velocity. So one observation is that like one modulo of, let's take the modulo sum, modulo prefix sum. Like how? Like 1 modulo of 5, it will be 1, so it will be 1 now. So next sum is 1 plus 2 modulo of 5, it will be again 3, so it is 3. Now take 3 plus 3 modulo of 5, it will be again 1. Now one observation, what is, I have already seen 1 here, I can easily search that one I have seen previously before or not. So I will check, okay, I have seen this. What is the position? I have seen this. The position is what? This index is 0, 1, 2. Index 0 I have seen 1 modulo of 1. Now if I just like discard this till this element index 0, and I am take only this 1 to current index 2, then what will the size 2, which is greater than equals to 2. They mention that the average size will be at least 2. So this is first of all condition is true. Now if I take the sum, like actually one also the observation is here, I have to share like sum modulo, like if I have to divisible by k, then sum modulo of k is equal to 0 should be. So if it has to divisible by is equal to 0, then if I get any, like if I get any x here and again I am getting x, then what is the modulo of some difference? X minus x will be 0. Now if I take the modulo of this k, it will be again 0, because if I subtract both the uh, modulo of some difference between those two elements, the in between elements will be actually contributing the 0 actually, 0 actually modulo sum. Here actually I have seen x. Again I am here I am seeing x. So what is actually is in between actually it's contributing 0 ultimately modulo of. So it will tell us, okay, if I take this element only, starting from the starting will be the next to this element, so it will be actually ultimate contributing is 0, because x plus y, again I am getting x. So what is actually ultimate? Y is equal to actually 0, have to be 0. Got it? So that's why I'll check the current modulo sum I have here, the current element, current index. Have I seen this modulo sum before? If I have seen this, so this will be our like one possible subarray whose actually modulo sum is 0. Modulo sum is 0 means what? Like it should be divisible by k. right? So I will check that, and and also I have to check the length is greater than equals to 2 or not, Subarray length. That's why I have to check the length also. Got it? So let's go to the code. So I have taken a map, or actually I'm storing the sum, modulo sum and the index. Okay. So initially I have seen 0 modulo at the index 0. Okay. Now I am traversing the each number. So for starting prefix mode is 0 initially. So I am adding the current 0 plus 1 modulo of 5. K is equal to here 5. Now what will I get? I will get 1. So I'll check in the map. I have seen this modulo sum. No, I have not seen. So store this. First time I have seen this. So what will you seen? Like modulo sum 1 I have seen at index 1. Why I plus 1? Because I have already taken this 0 for 0, because initially it will be I have not seen anything, so that's why I have to start from 0. Now for the next index, so what will happen? 1 plus 2 modulo of 5. What will get at 3? I have seen this. No, map in map it's not present. So go to the next again. Store this 3 at index 2. Now next is 3 plus 3 modulo of 5. So it will give 1. So have I seen this? Yes, I have seen this one before. What is the index of that? 1. So what will be the size of the current subarray who is actually contributing 0 in modulo sum? That index 2 to current index. What is the current? Current index is 0, 1, 2. 0, 1, 2. 2 means here 3, because I actually take shifted right shifted ones, right? So what is the length of this current subarray? 3 minus 2 plus 1. It's actually 2. Got it? So I'll check. Like I plus 1 is the current index I have here, and what is the last index I have seen. Got it? Actually, I can also write here like I have to start. What is the starting of the current subarray? This will be like ID I have seen. So ID plus 1. So that's why current index, this is ID plus 1. And what is the starting index of the current subarray? That contributing actually modulo contributing will be 0, modulo sum will be 0. Like it will be map of suppose x plus 1 next to the that index I have seen, because I have seen at index 1. So what will start on index 2? Got it? And the length how I'm adjusting plus 1. So actually you can check ID plus 1 minus MP of suppose x minus 1 plus 1. So that's why I do not have written this minus 1 plus 1. Got it? Got it, right? How are you adjusting? Okay. And I will check if it is greater than 1 means it's at least 2. So return 1, true. And after check all the things, if it is not found, so I have to return false. So at the end, I have written 0. Got it? So what are time to this? Like for I am traversing each number once, so time will be n, and for searching it will take log n. So time will be n log n. Got it? How I can optimize this? You can also the brute force approach, but time was size constraint is more. That's why that not be pass. TLE will give here actually how you got the logic. How you have to optimize.